called angles, we have to first understand how they're labeled. Might not be a bad idea. Angles, clear this one out for the glare. Angles are basically an easy way of defining them. Are going to be two rays. Put your chair flat, please. I don't want to ask you again. That's how the backs of these chairs break. Angles are basically two different rays that share a common endpoint. Now, we talked about that yesterday, or 2 days ago. We had opposite rays. Opposite rays were two rays that shared a common endpoint. They created a line. Now, you just gave me one of the types of angles was called a straight angle. That line was a straight angle. Okay. What does a straight angle measure? Do you guys remember? 180. Very good. Now, when we're talking about this idea of two different rays with the same endpoint, when you have that, this same endpoint would be here. When you label a ray, usually we have a dot on both sides. And sorry, when I drew this picture, the arrows didn't show up as prominently as I would like, but you get the idea. When we label these things, if I say this is ray B, A, and ray B, C, what's the common endpoint that they have? B. Do you know what that's called in an angle? What's that point called in an angle? Where they change, what's that? You said vertex, very good. So that common endpoint is called a vertex. So the common endpoint of an angle is called a vertex. When we label angles with 3 letters. That middle letter will always be the vertex. The direction of an angle doesn't matter. Just like the direction of a segment didn't matter. Segment AB was the same thing as segment BA. XY is the same thing as YX. Rays, on the other hand, the order always mattered because remember, your ray always started with the endpoint, and it went through whatever other point. When we deal with angles, the real important thing is that the middle letter is always the vertex. So textbooks, and usually you guys are accustomed to seeing this as a symbol for an angle. I change it ever so slightly. I put a little arc in it. My high school geometry teacher, Miss Bender, taught me that many, many, many moons ago. Moons, yes. Means a long time ago. I'm old. It's okay. Just nod and smile. You didn't have to be that quick with that joke. So when I say this, an angle, I'd say angle ABC, or I can say it's angle CDA. Okay. The reason why, and you don't have to write this down, but the reason why that I use this angle symbol with the arc in it is because that's a really badly drawn what? Circle. When you get into Algebra 2, your circle becomes what's called the unit circle. The unit circle gets placed on the XY coordinate plane, and what's located where the X and Y axis hit? What do they call that? The origin, very good. The origin here is the center of that circle. The center of the circle, these guys would be the radius, going to these spots here. The radius of a circle is the same all the way around. You guys remember that, right? We say that all radii are congruent, or that all radii are equal. Anyway, what happens is, as angles are created inside this unit circle, the angle measure itself, if I say this is 30 degrees, that central angle, the angle at the center of the circle is 30 degrees, and the arc that it hits is also equal to 30 degrees. How? It's It's not. The angle measure at here hits that angle part there. Well, let me ask you this. When you have a circle, how many degrees in a circle? There's 360 degrees. Are we okay with that? So if I have 360 degrees to go around a circle. Now, let's do this. How many degrees is it from here to here? 180. Okay, good. How many is it from here to here? 90. Very good. So when you start partitioning it out, cutting it in smaller chunks, this is 1/4 of a circle, 90 degrees here. 1/4 of a circle here, 1/4, 1/4. That's why there's 4 quadrants. You guys remember the word quad? Prefix is 4. Now, if I cut 90 in half, what do you get? 45. Good. Same idea. If I bring this into 45s, I have 1, 2, 3, 4, 5, 6, 7, 8 parts, right? What's 360 divided by 8? 45. Now, if I break this into 60 degrees, what's 360 divided by 60? 6. So you're breaking it into 6. 1/6. I do it again with the 30. It's 1/12 of the circle. Because there's 12 30-degree angles. You can turn 30 degrees 12 times to get all the way around. That's why that works. There's all these properties and stuff that come from, but basically the main idea is when you see this symbol written from me, it means an angle. Stand. Stand. Thank you. Thank you. This won't happen again now. So just a little different nomenclature from what I do versus others. That's just this little subtle thing. So if you see that little hook in there, that just means it's an angle. Okay?
What type of angle?
It doesn't matter. We'll talk about the angle types and things like that tomorrow, because then we'll worry about which is acute, which is obtuse, which are rights, and which are straight. Yep, yep, yep. And then lastly, the sides of an angle are the rays that make it up. Okay? The sides of an angle are the rays that make it. That common endpoint, so that common spot for the rays. So rays BA and rays, ray BA and ray BC create the angle ABC. When we work with angles, and eventually as we get into triangles, what gets weird with them is that there's extra letters. And you just have to be careful when you write them out. Make sure you put them in the correct order. And that's with a lot of geometry, as you guys know. You have to label things correctly. You have to use the correct vocabulary, nomenclature. Remember how we talked about nomenclature, how things are put together. We talked about RPO codes for car builds and stuff like that. So that's where this comes from. Questions of any of that? Not bad, right? Now, as we keep going into this, I'm going to draw back from what we did 2 days ago, or 3 days ago. We talked about this. Segment addition, remember that? What did segment addition basically boil down to be? Good. Everybody hear that?
No.
Small chunk segment plus larger chunk segment equals the whole segment. The only thing that had to occur was those 3 points on the line, or however many points, they had to be what? When they're on the same line, what do we call them?
Collinear.
Collinear. Excellent, excellent. So we had this thing where we talked about segment additions, where if I had W, X, and Y. In that diagram, does it say that WX is equal or congruent to segment XY? Why is that? Correct. There's no tick marks here, guys. So you can't assume that. You assume that, you're going to make an angle side out of you and me, and you're going to be wrong. You can say the word. It's okay. If you assume. No. It's okay. You know why? There's no ass in math. No, everybody with me. Come on. No, there's no ass in math. No, seriously, ladies and gentlemen, there's a reason why I'm saying this now. Because in a couple of months, or 6 weeks or so, we're going to start talking about what are called congruent triangles. And the way that I'm getting there. We're not there yet. But the reason why I'm telling you there's no ass, don't write this down. The reason why I'm saying there's no ass in math right now is because later on we'll talk about these things called congruent triangles, which have side, 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 angle, side, angle, side, oops, angle, angle, side, angle, side, angle. Do you see ass in math?
No.
So there's no ass in math. There's no angle, side, side in math. But there is no ass in math. And it's okay to say that. You get that out of our system now? Anyway. All right. Back here now. Thank you. When we talked about this a second ago now, when we add segments together, if they're collinear on the same line, you guys would say that WX plus XY equaled the whole thing, WY. So simply, if this was 12 and the whole thing was 37, what did you do to figure out the missing part? Very good. You just subtracted that out algebraically, if you will, or since it's numerical, you just press a couple buttons to calculate and realize that 37 subtract 12 gives you, nobody wants 6, they don't want to think their way through it the wrong way, 25. Okay? What do you think changes when I make this in terms of an angle? Yeah, what do you think changes? Nothing. Nothing changes. When we get to angles, nothing changes. Yes. When you're talking about this thing called angle addition postulate, if you will, eerily similar to segment addition. Be a smart idea. You don't need one. Doesn't have to be perfect. Use the side of your phone. It doesn't matter. Again, it doesn't have to be drawn perfectly because you're just doing a quick little visual here. When you think about this, when you had segment addition, the points had to be collinear. They all had to be on the same line, right? Otherwise, it wasn't going to work cleanly. Here, instead of being what we call collinear, you have to have two things that happen. Angle addition means that you have to have two angles that share a common vertex and a common side. Where's my common vertex here? At B. What's the common side? BD, very good. Okay. So in order for angle addition to work, you must have common vertex. You guys okay with me using vert for that? I know vertex is so many extra letters. I'm with you. That's why I went back to it. So if you have what's called a common vertex and a common side, then we can do basically the exact same thing we did with segments. Small angle plus small angle equals bigger angle. That's all it is.
What is that?
Then a small angle plus another angle will equal a bigger angle. Yes, ma'am. I'll get to that. I know what you're talking about. And I'll explain that when I throw some numbers in. Sorry, my handwriting gets sloppy from time to time. Yeah, right. There was a specific class in college that taught you how to write badly.
What?
20%. Come on, keep up. 80% true, 20% made up. So here, when I label out my two angles, if you're looking at it, I can say that angle, and this is where handwriting really needs to try to write neatly. When you start putting angles together, you've got the angle symbol, you've got three letters you're working with, and it can just look messy if you're not careful. I'm trying. Fontana has really good handwriting. Plaskota's got great handwriting. I, I, there are times that my handwriting's better than others, but I try. So here, like I was saying, when you wrote out segment edition, like we did a second ago, question? Then don't worry about it. When we talked about this a second ago with segments, small segment plus small segment was bigger segment, just two letters each time. Here you've got symbols, you've got three letters, you've got extra stuff you're putting down on paper, so you got to be cautious as to how you write it so you don't make a mess of it. And that's one of the things, you got to be clean with your writing. Now, what happens if I say that this angle is 36 degrees? You guys remember how angles are measured in degrees? Okay. A lot of times textbooks will put a dot, sometimes they'll put a little circle here. Is it the end of the world if you forget to do that? Same thing. Technically, the true symbol would be this little degree symbol, but if you put a little dot there, it's fine. But if you forget, am I going to be mad at you? No. It's really not in the grand scheme of things, it's not that big of a deal. If this one's 36 degrees and this one is 43 degrees, again, you can't assume that. You want to make an angle side out of yourself. Do you know if it was a 90-degree angle, what would you see? What is it? Yeah, exactly. You would see a little box, and I have an example that actually coming up next to show you how that looks like. Here, we know that the small angle plus a small angle would equal the large angle. So what's 36 and 43? That's what we're looking at. Now, will it change any? Yes, ma'am. Yes. Like this stuff here? Yes, because when you're doing something like this, if you're using three letters, if you don't tell me what you're using the three letters with, I don't know what you're using. I don't know if it's a plane, I don't know if it's a triangle, I don't know if it's an angle. You have to use those symbols to show what it is. Okay? So, will it change any if it looks like this? Exactly. It's the same exact thing as we're doing with segments, guys. But now, instead of just being straight across from one another, segment lengths, we've got angle measures. We know, according to the diagram, the large angle, angle ABC, the whole thing is 110. One chunk of the whole angle is at 35 degrees. What's left over for the other part? Exactly. All you're doing in this case is that we know that 35 plus something will equal 110. And you're setting yourself up to work with a one-step equation. Now, do you have to put an x there or a variable? Can I use this just a question mark and just be fine with that? Yeah. Because you're just looking to find out what the value of angle DVC is. And as you can see, it's just subtracting. So if I subtract 35 from 110, I know you guys already said it was what, 75? Are you just subtracting it out? You did these problems with segment addition. It just so happens they're not in a straight line. Okay? So this angle winds up being 75. Again, angle symbol, you put it there, great. If you don't, not the end of the world. Technically, yes, but I'm happy if you tell me that the angle's worth is 75. That, okay. Now, so the other thing we were saying a second ago about the whole right angles, in diagrams, there are certain things that you'll be able to infer information from. You guys remember what the word infer means?
No.
You can take specific things that are given to you in a diagram and say that this is what this means just by looking at the diagram. For example, if I had this, what would that angle measure? 180 because it's straight across. Now, when you get into this, sure. What does that little square mean? 90. That means it's a right angle. Anytime you see that little box in a corner, it means it's 90 degrees. Stands for right angles. Okay. This will come into play a lot when we talk about congruency in triangles. It's one of the things you can take from a diagram to say to be true. It's something you can use for an argument. It's something that you'll be able to prove because that's what it says it is. Okay. So without knowing the numerical value, and I see that little square in the corner, I know that 26 plus something has to equal. Again, you're setting yourself up. What do you do to find the something? See how this is not going to be very difficult today? And your something is? What haven't we done with these yet? What haven't we done with this style problem yet? Equations, variables. Is it okay to use those? Yeah. Let's go back a second. A second ago, I had a picture of a straight angle. You guys remember that? Lines going, just a segment going across. I go back to this one. Perfect. The inference that you can make from a diagram like this is that you have two angles that create a line. That line is what you call, you guys brought this up earlier when we were classifying angles, it's called a straight angle. Straight angles measure how many degrees? 180. So I know that when I start from here to here, if I wanted to figure out the measure of both of those angles, I know that those two angles have to add up to equal 180. So what's 2x plus x?
3x.
Perfect. Yeah, 2x. And what's x equal to? 3x equals 180. And to get x by itself, you just divide out by 3, which means one angle is going to measure 60. And what's the other angle going to measure? 120. Perfect. Because 60 plus 120 should equal 180. If it doesn't, you know you done goofed. Okay? Does it get more complicated? It shouldn't, because the only thing that's left is just multi-step. Okay? It doesn't get any more crazy because, remember guys, the idea of adding two segments together didn't change throughout the whole time. The idea of adding two angles together isn't going to change either. You're just looking at a different diagram. The process and the procedure that you do is exactly the same. Okay? For example, back to the same idea. You've got you get a given angle, given diagram. You're given information. I'll give you a second to draw this up here. We've got, you're given that that M in front of the angle, that means measure of the angle. That's what that stands for. Measure of angle NRQ equals 78 degrees. Find the measure of PRQ given the information. So I have two angles that share a common vertex. That common vertex is at R. Their common side is that ray RP. So I know that those two angles have to add up to equal to large. So that's what the diagram says. Algebraically then, what do you write down? Remember, go back to segments. If this was 3x plus 1 and this was 7x minus 3 and the whole thing was 40, what did you do? Okay. What changes here? Nothing. The only thing that changes is you're not straight across from one another, you're at an angle. Two angles add up to equal to large. I know that in this case would be 8x plus 7 plus 4x minus 1 is 78. Two angles add up to equal to larger. That's what we're looking at today. Algebra-wise, from here is pretty quick. Combine your like terms on the left-hand side. What's 8x and 4x? 7 minus 1. Two steps from there. What do you got? And last but not least, divide by 12 to get 6. Good. And I don't know, typical geometry problem, not just solve for x and do something with it. Which one do we put it back in for? Good. For the 4x minus 4 because it's asking you to find PRQ. So, what's 4 times 6? Subtract 1. There you go. Now, it doesn't say to do this, but does it take a whole lot of time to go back and double check, make sure you got the right answer by checking the other part? You got a calculator. What's 8 times 6? Add 7 to it and you get? What's 55 and 23? And you did fine. Yes, ma'am. No, angle PRQ will equal 23 degrees. The value of x equals 6. Just like we did with segments, a lot of times you had to solve for x and then substitute back in to find, AD or whatever it was asking you. Same idea here. They're going to ask you to solve the algebra to get to another step. Right? When we had congruent segments, we marked things with tick marks. Remember that? When you have congruent angles, they also use tick marks, but they look differently in diagrams. Let me show you what I'm talking about real quick. If you have a diagram, how many angles do I have here? Six.
What? 4, 5.
You know all 6?
Yes.
Here. Oh, okay.
Okay. 1, 2, 3, 4.
I count that one twice.
I did.
Or did I miscount one?
No. I did.
Was it?
Okay. We're gonna try this again.
Well, here, hold on. So we have 1, 2, 3, 4,
5. I was
5.
right.
Wait, I just lost count. 1, 2, 3, 4, 5, 6. Yeah, there we go. So now, back to the first one. When you have congruent angles, or angles that are equal to each other, you will also see tick marks, but they put them like this. That little hook in the angle means that those two angles are congruent. And I think you've seen that before when you talked about isosceles triangles. Remember you had isosceles, you had the congruent lengths, created base angles that were the same. Same idea. It just means that those two angles are equal. Okay? Reason why I said that because there's a problem like that in your homework where you have two angles that are equal. So if angles are equal, what do you do algebraically? Means they have to equal each other, don't they?
Yes.
So I posted the problems. I want to say it was on page 32. Does this sound right? Is it 32? And it was numbers 22 and 23. Yes, ma'am. Was it 29 and 30? Thank you. Again, and that's the thing. If you're pulling stuff up on Slater and stuff, that if you're doing it to check your work, that's great. If you're doing it to copy down answers, well, then you're just shooting yourself in the foot. And that's one of the reasons why a lot of times I don't collect most of the homework, because you can do that with everything. It's there for you to learn, and that's the whole point. You have to decide when is it time. When is the time and the place to be able to do that? Okay? Because if you're learning to do things and then you're checking your work, that's awesome. Because then when you get to your quiz, you'll know how to do it. If you're doing it just to push papers and go back and forth to say, oh, look at me, I did my homework, and then you do crappy on your quiz, well, that means you're just copying stuff. So, and that's why there's not as, I don't put as much emphasis to a lot of that, to a certain extent. Now, there will be times when I put more emphasis on problems, and those will be problems that I come up with on my own. That'll be a little bit more difficult for you to find every single solution known to man, because there are ways that you still know how to do that. It's okay. Tomorrow we'll do more of the angle stuff as far as the types, like you guys talk about queued up twos and all that. A little bit more of the algebra. Friday we'll do a lot of algebra with these things. I've got some word problems, not word, but some problems, not word problems, work problems. We don't do that many word problems in geometry. There's a handful here or there, but it's not that it's going to be anything horribly bad. Most of the word problems that we come across in geometry tend to have diagrams to them, so they work out pretty quickly. You don't have to worry about screwing stuff up. There is a textbook up here by my water bottle if you want to take a picture of it. It's just one page.